Hi everyone, my name is Michael, Kינן. I am extremely excited to be here today. You have to remember I'm only 17 and you're all like a decade older than me. So this is a little stressful, but I'll try to make it interesting and fun. So again, my name is Michael. I learned here in Jerusalem in Himmelfarb School. My principal is actually here, so hi. In the past 2 years, I've been participating in the Alpha program here in the Hebrew University in Jerusalem. My supervisor, Hadar, is also here, and Shira, the manager of this program, is also here, so again, a lot of stress. I will present to you today my project that I've conducted at the university in the past 2 years. But first, a little bit about the program itself, because the social side of the program has been so inspiring and so much fun for me. The Alpha program combines social and science together in a way that is truly amazing. What they do is they take students from all around the world, from all around Israel, and they put them together once a month. They put them together and they give them certain, we go on trips and they show us lectures, they give us lectures, and then each student or a pair of students go on to conduct their personal research. But what is really fun and interesting is that you get to meet so many nerds that are exactly like you, and if Instead of me sitting at home and not really doing anything, I get to actually interact with other human beings and improve on my social skills, go on trips, and really do amazing things. Here you can see some of my new friends that I met during the summer camp that we had last year. Here is Hadar in the program, right over here. This is Hadar, my supervisor, and this is Rafael, who was my lab partner during these 2 years. He's an amazing person. And what I really want to emphasize is that Alpha managed to build a society of nerds and scientists and little children who really like to conduct science. And I got to experience many different fields, and not only math and computer science, which is what I do, but also learn about biology and chemistry and everything that I can possibly learn about. So I am just one of these students, and I'm here to introduce and to tell you about my personal project. So I assume most of you are familiar with the ALS disease. The ALS disease is a disease that causes complete paralysis in the human body, meaning you can't move your muscles, you can't move your eyes, your legs, your hands, and it is very hard and almost impossible to communicate with the outside world. The thing is that the brain stays completely normal and can act as anyone of us can, and can think normally. We know this because people like Stephen Hawking, who died this year, was managed to build mathematic models and write amazing books, meaning his brain was completely intact and normal. Shai Rishoni, who also recently passed away, was an ALS patient, an Israeli ALS patient, who worked on improving the awareness for the disease in Israel. Now, to just understand how this communication is important for these patients, I want to read to you a quote from Shai Rishoni. Shai Rishoni says this: "Of all the capabilities I lost over time, the ability to communicate was the most significant. Of all the fears I had in which I conquered, I am left with but one final fear: the fear of not being able to communicate, to be trapped inside my own body with a clear and full conscious mind and not have the ability to freely communicate a single thought." This is terrifying. And this is exactly why in my research I wanted to help these patients communicate in a faster, easier, and more convenient way than they ever could before. So let me tell you exactly how I did that. First of all, let's start with what we have today. What we have today is an interface called the P300 Speller, which is amazing. What it allows patients to do is wearing an EEG helmet, as you can see right here. This EEG helmet measures electrical activity in the brain, and it can recognize a signal called P300, which shows us that there is a certain surprise. So the way this works is these patients look at this table on the screen right here, and they just focus with their brain on the letter which they want to type. They just focus. They don't need to move any muscles, only with their brain. The rows and columns in this table flash, and when the row which your letter appears in, for example, D, flashes, you can see in the brain the P300 signal. And this is truly amazing, and then the program is able to identify which letter you were thinking of, and it types it to the screen. So this allows patients who are fully paralyzed to type words and sentences and paragraphs and even complete books using only their brain. Now this is really incredible, but there is one very main deficiency, and that is time. It takes approximately 30 seconds to type one letter in the interface, which translates to 15 to 20 minutes to one simple sentence of 5 to 6 words. A simple sentence like I might say right now. Now this is a lot of time. It is far from ideal for day-to-day use to these patients who this is their only way to communicate with the outside world. And this is the problem that I tried to solve in my research. Now let's understand why this problem exists. 2 reasons. First of all, unlike we as human beings communicate, we communicate using building words into sentences, into paragraphs. Here, the patients have to type one letter after another, and let's not forget about the space character, which also takes more time. And because we want to be accurate in recognizing what letter the patient is thinking about, we need to flash many times on each row and column, which leads to 30 seconds to one character, which leads to 20 minutes for one sentence. So, this was the deficiency that I tried to solve in my research. And the idea actually to my research came from my grandfather, whose best friend is an ALS patient, and I told him about this interface. And he immediately told me, you know, I have this app on my phone, which allows me to predict what words I am trying to type. We all know this from Google, who offers us how to complete the sentences. And he also had this special keyboard that offered him words based on the letters that he typed before. So he told me, Michael, why don't you incorporate this into what already exists? Thank you. Sorry. And that was the idea that I took. And this is called a word prediction model. This is very efficient in allowing us to predict what the user is trying to type based on what he already typed. So this is how I incorporated this into the P300 interface. We start normally. We start typing your sentence like so. You type one letter after another. But then when the word prediction model gives us a small amount of words that have a high probability to be typed, and by probability I mean the word apple has more probability than the word apprehension. We use it much more, so it has more probability to be typed. So when we have this list of words, this table of letters changes into a table of words. And then the patient is able to focus not on their letter now, but on their word that they are trying to communicate. And then the rows and columns will flash, and the word will be inserted into the text. So instead of typing H-E-L-L-O, I'm now able to type H and then immediately hello, which is much faster. And not only that, I wanted to make sure that it's not annoying sometimes as we have on our phones, which is, we all know can be annoying. So I added this return button here that allows the patient to focus on this and then go back to the letter table to make sure that it is convenient and as easy for the patient to fix his mistakes. Now, let me show you a short video of how this works. This is me here using this interface, using the EEG helmet, which is extremely amazing. And I am just focusing here on the word I'm trying to type. I am going home. You will see now this word table that I'm focusing on. It is going to start to flash. And all I need to do is focus on my word home, and it will be inserted into the text. You see that we need to flash many times, which is why it takes so long to type one letter or one word. In a second, it will finish, and then instead of typing H-O-M-E, I only need to type home, which is so much faster because now also we can eliminate the space character, which before the patients needed to type, but now it can immediately insert a space character after that. Now, you may be wondering, okay, cool and all, but what are actually the results? How much is this better? Then we took 6 research participants and gave them 2 random sentences to type, once in the basic interface and the second time in the enhanced interface. And the results are in front of your eyes. The time it took to type a sentence in the enhanced interface was twice as small as the basic interface, meaning the typing speeds are twice as fast in the enhanced interface. And this is incredible, and I was very happy when we discovered this, because this means the difference between 20 minutes for one sentence to 10 minutes, 10 minutes to 5 minutes. And we are cutting the time by half, and this is extremely massive and an extremely important improvement for these patients, which this is their only way to communicate with the outside world. So to conclude, what I've done in my research is I integrated a smart word prediction model that is based upon probabilities, and I made a better and easier interface and faster interface that allows these patients, these around 500,000 ALS patients around the world, to communicate with their loved ones, their caretakers, their families, people that before they had no ability to talk to, and are now able to communicate with them twice as fast as they could before. This has been my research, and I truly want to thank everyone who helped me throughout this journey. Hadar, again, was my supervisor, Professor Naftali Tishby, where I did my research, all the people from the Alpha program, Dr. Shira Hirsch, Anat, Ayelet, and Alon. You have really been amazing, and you helped me so much throughout this journey, and I'm so thankful to be here to tell you about this today. Thank you very much.